In here we study the movement of shapes on a plane. We call it transformations.
It includes reflections, translations, and rotations. Transformations are movements that take place in a graph, and in more advanced models are the basis for the programming that controls the robots for industry and entertainment. We start with reflections. A reflection implies a mirror image of a figure or design. This graph shows a reflection of an image from quadrant 2 to quadrant 1. Notice that reflection must take place over a particular axis and that they are reversed. This particular reflection is in respect to the y-axis. Therefore, every corresponding point of the letter E in quadrant 2 is at the same distance from the y-axis in quadrant 1. For example, find the reflection of the letter V starting in quadrant 4 with respect to the y-axis and then with respect to the x-axis. The solution is like this. The points that define the letter V in the fourth quadrant are, from left to right, 1, -1, 2, -1, 3, -7, 4, -6, 5, -6, 6, -7, 7, -1, and 8, -1. The reflections over the y-axis keeps the same values for y, but the size of the x values change signs. -1, -1, -2, -1, and so on. The second reflection is going to quadrant 2, where the x values are negative and the y values positive. Therefore, again the values will be the same, except that the signs will be the opposite, negative, positive, to the original in quadrant 4. Now to translations. Translations are movements which go up, down, right, or left. For example, in here, make a translation of triangle ABC 5 units to the right. The original position of triangle ABC was -3, -2, -2, -6, and -4, -6. Because it is to the right, all the x values of the coordinates change, but the y values stay the same. Simply add 5 to each x. -3 plus 5 equals 2. -2 plus 5 equals 3. -4 plus 5 equals 1. The new coordinates are 2, -2 for D, 3, -6 for E, and 1, -6 for F. Another example. In here, make a translation of quadrilateral ABCD 4 units to the left and 6 units down. Because the translation is both to the left and down, both coordinates will change. The original figure is at 3, 6, 5, 7, 6, 1, and 1, 1. Translation to the left means that the x coordinates changes -4. The new coordinates after the first move are -1, 6, 1, 7, 2, 1, -3, 1. In translation down, the y coordinate moves -6. The new coordinates after the second move are -1, 0, 1, 1, 2, -5, -3, -5. Now to rotation. Rotation is measured in angles. Also called angular motion, it is the circling motion around an axis. All rotation must have a center of rotation about which the object moves. Rotation is always clockwise. For example, rotate triangle ABC 60 degrees using point 8 as the center of rotation. Remember, rotation is always clockwise. Because the rotation took place around point A did not move. However, both point B and C moved. In rotation, points farther away move more than points closer to the center of rotation. Therefore, point B moved less than point C. If the center of rotation changes, for example, from point A to point C. Notice then that the new location of the triangle will be completely different. To wrap this up, let's talk about axes or lines of symmetry. An object is said to have an axis of symmetry if, when folded about an axis, both sides of the fold match. In other words, there is mirror symmetry of half of the object. For example, a circle has an infinite number of axes of symmetry, while the number 7 has none. Another example. Find the number of axes of symmetry of a square. The number of lines are 4, which is the number of axes, horizontal, vertical, and both diagonals.